Hi everyone, in this video I am going to solve Cambridge International AS and A-Level Mathematics Paper 2 Pure Mathematics 2 in a session October-November 2024 Paper 2-1. So let's start with the first question. Question number 1, the variables x and y satisfy the equation a to the power 2y equals to e to the power 3x plus k, where a and k are constants. The graph of y against x is a straight line. The graph of y against x is a straight line. Part A, use logarithms. We have to use logarithms to show that the gradient of the straight line is. We need to show that the gradient of that straight line is 3 by 2 natural log of a. Okay, so we have the line is a 2y is equals to e 3x plus k. For this e, it is better to take a natural log on both sides. So here we can say take natural log on both sides. Okay, so here we can say natural log a to the power 2y equals to natural log e to the power 3x plus k, because the graph of y against x is a straight line, right? So if it is a straight line, you have an equation y equals to mx plus some y-intercept c, right? Y against x, and the gradient means that m value should be equals to this. Okay, now use a property of log. So this power comes before the log. 2y natural log of a is equals to 3x plus k into natural log of e, and we all know that natural log of e is always equals to 1, right? Okay, so now just put this equals to 1 and we can say 2y natural log of a is equals to 3x plus k. Okay, now what y is, y would be equals to 3x plus k, and everything divides by 2 natural log of a. Okay, so now we have to convert it into y equals to mx plus c form. So y equals to 3 divided by 2 natural log of a times x plus k divided by 2 natural log of a. Now this is your straight line y against x, right? And what is the gradient? So here we can say the gradient of that straight line is the m value, or the coefficient of x, which is 3 over 2 natural log of a. So what is in the question? That we need to use logarithms to show that the gradient of that straight line is 3 by 2 natural log of a, and we have proved that its straight gradient is 3 by 2 natural log of a. So this is the gradient, right? Now for part B, given that the straight line, so this straight line passes through the points, the first point and the second point, find the values of a and k. So this straight line passes through 2 points and we have 2 unknowns a and k. Okay, so substitute these 2 points. The first point is the x value 0.4, the y value 0.95. So just substitute these two values. Y is 0.95. The y over here, this is equals to 3 divided by 2 natural log of a, and the x value 0.4 plus k over 2 natural log of a. Okay, and the second point, we can, before substituting the second point, it is better to take something common. Yeah, or just let me substitute it. The second point, the x is 3.3 and the y point is 3.80. Okay, so the y is 3.8 equals to 3 over 2 natural log of a. The x is 3.3 plus k over 2 natural log of a. So this is my first equation and this is my second equation. Okay, now we have two equations and two unknowns. We can solve these two equations simultaneously by using a method of substitution or elimination. So it is better to subtract the two equations. Okay, let me solve 3 by 2 times 0.4. Okay, 3 times 0.4 and divided by 2 is 3 by 5 or 0.6. So here we have 0.95 equals to 0.6 divides natural log of a plus k divides 2 natural log of a. And the other equation is 3.8. This would be equals to, what is 3 by 2 times 3.3? 3 times 3.3 divided by 2. This is 3.3. 4.95. 4.95 divides natural log of a plus k over 2 natural log of a, right? Okay, now let me subtract the two equations. So when we are subtracting these two equations, we can change the signs, negative and negative. Now this positive and this negative is cancelled out. Okay, we are just left with this. So 0.95 minus 3.8. So 0.95 minus 3.8, this would be negative 2.85 minus 2.85, and that is equals to 0.6 over natural log of a minus 4.65 over natural log of a. Okay, the base is same, just subtract the numerator. 0.6 subtract 4.95, that is minus 4.35. Negative 4.35 divides natural log of a, negative 0.85. Okay, now we can cancel these two negative signs and we can easily solve for the a value, right? So cross multiply natural log of a over here, and 4.35 divides 2.85. Okay, let me simplify. 4.35 divides 2.85, that is 29 over 19, right? So this is 29 over 19. So what is a? A is basically e to the power 29 over 19. This is your a value. Okay, so we just need to solve for the values of a and k. Okay, no significant figures are mentioned, right? That how much significant figures we need to find it out. Okay, this is up to you. So figure out what is e to the power answer, which is 4.60119 or 4.6, we can say. This is rounded to 4.6, and from here we got the a, which is 4.6. So we have done with the first value a, which is equals to 4.6. Now same we have to solve for k. So just substitute the a value into your first or your second equation and solve for a. Okay, so here we can say put a is equals to 4.6 in equation 1. So what is my equation 1, which is so this is my equation 1. I pasted my equation 1 over here, right? So just substitute the value. So 0.95 is equals to 3 times 0.4 divides 2 natural log of 4.6 plus k divides 2 natural log of 4.6. Okay, so this becomes 0.45 is equals to 1 by 2 natural log of 4.6 is common, and 3 times 0.4 plus k is left. Okay, now cross multiply 0.95 is multiply with 2 natural log of 4.6. This is equals to 3 times 0.4 and plus k. Okay, now to solve for k, we can say 0.95 multiply 2 times natural log 4.6 and subtract 3 times 0.4. This is your k value. Let me solve everything. Okay, so here we have the k value 0.95 multiply 2 times natural log of 4.6 bracket minus 3 times 0.4 bracket 1.699 or 1.7, you can round it to. So from here the k value is 1.7. All right, so we have done with both values, the values of the value of a and the value of k, because we just need to find the values of a and k, right? Question number 2, solve the inequality absolute of x minus 7 is greater than 4x plus 3. Okay, so as you can see in this inequality, this is the absolute function and this is not an absolute function. There is, when there is absolute on both sides, so it is better to take squaring on both sides and simplify. You will get a quadratic equation and you will get two roots, right? But now we have absolute only one side of the inequality. There is no absolute function on the right side. Okay, so here we have to consider two cases. So the first case, okay, so we can say case 1, sorry. So in case 1, we have to let that absolute of x minus 7, this should be greater than equals to 0. Okay, so absolute of x minus 7 is greater than equals to 0. It means x minus 7 is greater than equals to 0, or x should be greater than equals to 7. Okay, right. Now, if we are solving this case, this implies we have to take this x minus 7 is greater than 4x plus 3. So first case, we have to consider this absolute function is positive, right? So when this absolute function is positive, right, we can x, the resulting x should be greater than equals to 7. It is 7 or more than 7. Let me solve the resulting x. Okay, so x minus 4x is greater than 3 and shift the 7 becomes plus 7. This is minus 3x is greater than 10, or x should be less than 10 over negative 3. And this is negative 3.33 recurring. Okay, now here the x value is less than negative 3.33, right? And we have to find the x, what is the range of x. The x should be 7 or more than 7. So here we can say x, or we can say x is greater than equals to 7. X should be greater than equals to 7, and here we got x is less than minus 10 over 3. So we have no solution from here. If that x value is 7 or more than 7, then we have some solution from case 1, right? So here we have no solution from case 1, right? Now let me do the second case. So we can give the reason no solution because x should be less than minus 10 by 3, which is not satisfying x greater than equals to 7, this condition, right? Okay, so we have no solution from case 1. Let's study case 2. So in case 2, we have to assume that this absolute function should be less than 0, or x minus 7 should be less than 0, or x should be less than 7. Now the resulting answer should be less than 7, right? Now let's see the resulting answer is less than 7 or not. Okay, so this means minus of x minus 7 is greater than 4x plus 3. Okay, minus x plus 7 is greater than 4x plus 3. We have minus x minus 4x is greater than 3 minus 7. What I did, I shift the 4x on the other side and 7 on the other side. This becomes negative 5x, and this is greater than negative. From 7, if you take away 3 we have -4. So you can cancel the negative sign on both sides by reversing the inequality. So x should be less than 4 by 5. So 4 by 5 is basically 0.8. So here the x should be less than 0.8. So the x value should be less than 7. So the less than 7 is this value is in the range that 0.8, this value is in the range that it should be less than 7. Less than 7 values means 6, 5, 4, 3, 2, 1, 0, -1, -2. So this value is in the range, right? So here we can say the only solution is x is less than 4 by 5. So this is the only solution for that equation, because it satisfies the condition that here x is less than 4 by 5, or x values should be less than 0.8, and which satisfy this condition that it should be less than 7. So you have to do such type of question by considering two cases: when you have absolute sign on just one side of inequality. When you have absolute function on both sides of inequality, it is better to take squaring on both sides. I hope this makes sense now. Question number 3, the function f is defined by f of x is tangent square half x for x is between 0 to pi. Part A, find the exact value of f prime of 2 by 3 pi. Okay, so we need to differentiate this function basically, right? Okay, so we have f, so we need to find df over dx, or we can say f prime of x, right? So applying the power rule, so power is 2, the base function is tangent x by 2, power -1, and the derivative d by dx of the base function, which is tangent x by 2, right? So here f prime of x would be 2 tangent x by 2. 2 minus 1 power is 1. And what is the derivative of tangent x? Tangent x derivative is secant square of x. Secant square of x by 2, and x by 2 derivative is 1 by 2. Okay, now this 2 and this 2 is cancelled out, right? And you will get f prime of x, that is equals to tangent of x by 2 into secant square of x by 2, right? So secant square is f prime of x would be tangent is sine x by 2 over cos x by 2. Sine over cos is tangent, secant is a reciprocal of cos, so cos square of x by 2. So this whole thing is basically f prime of x is sine of x by 2 divides cos cube of x by 2. Okay, now let me substitute the x value, which is 2 pi by 3. We need to find its exact value, right? So we can say let x is equals to 2 pi over 3. Okay, now f prime of 2 pi by 3, this is equals to sine 2 pi over 3 multiplied by 2, this 2 divides cos cube of 2 pi by 3, and this 2, oh sorry, times by 2. Okay, this 2 and this 2 are cancelled out, and here we have sine of pi by 3 divides cos cube of pi by 3. Okay, let me solve this. It should be in radians, right? First, sine of pi over 3 and bracket, and divide bracket cos of, sorry, pi by 3, pi over 3, we have to put a bracket, and whole bracket it's cube. Okay, 4 root 3. This is the exact value. So f prime of 2 pi over 3, this is equals to 4 square root of 3. So we just need to figure out what is the exact value of the derivative at 2 pi by 3. So its value is 4 pi by 3. Now for part B, find the exact value of integral 0 to pi by 2 f of x plus sine x dx. What is the function f of x? F of x is tangent square half x, right? So let me write the function f of x is tangent square of x by 2. Okay, so we can use this identity that tangent square theta is secant square theta minus 1, because the integration of tangent square is not possible, but the integration of secant square is possible, right? So let me replace it. So here we can say integration from 0 to pi by 2, f of x is secant square of x by 2 minus 1 plus sine x with respect to dx. Okay, so the integration of secant square is tangent, so tangent x by 2, and the derivative of x by 2 is 1 by 2, minus 1 integration with respect to x is just x, sine integration is cos x, so it's minus cos x. Yeah, because the derivative of sine is positive cos and the integration of sine is negative cos. Okay, now here we need to put the limits from 0 to pi by 2. Further simplification, this is 2 times of tangent x by 2 minus x minus cos x. We need to find the exact value, right? Yeah, the exact value. Let me put the limits from 0 to pi by 2, substitute the upper limit. So this becomes 2 tangent of pi by 2 and multiply by this 2 minus pi by 2 minus cos of pi by 2. This is the upper limit. Subtract the lower limit is 2 tangent 0 by 2 is 0 minus cos of 0. Okay, so this is 2 tangent pi by 4, tangent of pi by 4 minus pi by 2 minus cos of pi by 2 minus. Okay, so what is tangent 0 and cos 0? So tangent of 0 is 0 and cos of 0 is 1. So this is 0 minus this is 1, right? Let me simplify this further. We know that tangent pi by 4 is just 1, or you can solve it. Let me show you. Tangent of pi by 4 is 1. And what is cos of pi by 2? Pi by 2 is 0. Cos pi by 2 is 0 minus pi by 2 minus 0, and this negative and negative becomes positive 1, right? So this becomes 2 minus pi by 2 and plus 1. 2 plus 1 is 3. 3 minus pi by 2. Okay, so this implies the exact value is 3 minus pi by 2 for this integral. This is the exact value of the integral. 2 plus 1, 3, and minus pi by 2. Question number 4. The polynomial p of x is defined by p of x is a cubic polynomial where a is a constant. It is given that x plus 2 is a factor of polynomial. If x plus 2 is a factor, then you can put x plus 2 equals to 0. So x value is negative 2. If it is a factor, it means the polynomial at x equals to negative 2 should be equals to 0. Okay, part A, find the value of a. So use this equation that the polynomial at x is equals to negative 2 should be equals to 0. So a, the x value is negative 2, its cube. Wait. So a negative 2 cube minus a negative 2 square negative 15 into negative 2 plus 18, this should be equals to 0, right? 2 cube is 8 and negative 2 cube is negative 8a minus a. 2 square is 4, 4 times a plus negative times negative positive 2 times 15 is 30 and plus 18 that is equals to 0, right? In 8 when you add 4 negative 12, okay, and this becomes 8 and 4 so it is 48 negative 12a, this is equals to 0, right? Further simplification, we can say negative 12a should be equals to negative 48. So cancel the negative sign. So a would be equals to 48 divides 12. And we know that 12 times 4 is 48. And here you will get the value of a, which is equals to 4. So we have done with the a value, which is 4. We just need to find the value of a. So when we have the value of a, just substitute into the polynomial ax cube minus ax square. So the polynomial p of x is ax cube minus ax square and minus 15x plus 18 minus 15x plus 18. So this is how your polynomial look like. Yes. Now for part B, hence factorize p of x completely. We need to factorize this polynomial completely. So as we have given that x plus 2 is a factor for this polynomial, so it is better to use synthetic division method. Synthetic division method. Because in synthetic division method basically reduce the power of polynomial, right? Okay, so in synthetic division method, sorry, we need to draw this line and the line over here, right? So just write down the coefficients. Coefficient of x cube 4, coefficient of x square negative 4, coefficient of x minus 15, coefficient, the constant is 18. Okay, and we know that x plus 2 is a factor. If we know the one factor of this polynomial, right? X plus 2 is a factor, so take negative 2, bring the first term as it is 4. 2 times 4, 8, it becomes minus 8. Minus 8 and minus 14 minus 12. 2 times 12, negative times negative is positive, 2 times 12 is 24. Okay, from 24, if you take away 15, we have 9. 2 times 9, 18 with a negative 18, and we have 0 over here. So here you can reduce this polynomial. Let me show you how. So here we have x plus 2 in the bracket, and we have this, the other one. Before, the polynomial was cubic, right? So if I can write the polynomial here, p of x, okay, this polynomial is now p of x is x, this is x value is negative 2. So how do we write this? X plus 2. So when you solve it, you will get x equals to negative 2. And now before the polynomial was cubic, now the polynomial is quadratic. Okay, second degree polynomial. 4 is a coefficient of x square, negative 12 is a coefficient of x, and plus 9 is a constant term, right? Okay, now we need to factorize the other one, right? Okay, so the polynomial p of x becomes x plus 2. This is 2x whole square minus 2 times 2x times 3 plus 3 whole square. So what I did over here, I make a minus b whole square. So 4x square, basically 2x whole square is 4x square, minus 2 times the first term 2x, the second term 3. 2 times 2, 4, 4 times 3, 12, negative with x, negative 12x, and 3 square is 9. So this is a square minus 2ab plus b square. So the formula a square minus 2ab plus b square. So I close this formula, which is a minus b whole square. You will get the second factor. Right, so polynomial p of x in complete factorized form is x plus 2, and the other one is 2x minus 3 whole square, because a minus b whole square. So the first term a is 2x, we have a minus sign, and this is 3, its whole square. So this is a complete factorized form for this polynomial, right? Now for part C, solve the equation polynomial cosecant square theta equals to 0 for theta is between minus 90 to plus 90 degree. Okay. So for minus 90 to plus 90 is basically, we can say this is 0 and this is 90 degrees. So when you move anti-clockwise, you have 0 to 90, and when you move clockwise, you have 0 to minus 90. So in the first quadrant, all trigonometric ratios are positive. In the fourth quadrant, only cos is positive. Okay, so in the first quadrant, your theta value is your base angle, and here you will get theta is negative of the base angle, because we're just dealing with these two quadrants, first and fourth, according to this domain, minus 90 till 0 and 0 till 90. So 0 to 90, when you move in this direction anti-clockwise, this is 0 to 90, where all trigonometric ratios are positive and theta is your base angle or the principal value of the angle, right? And for 0 to negative 90, you have to move in clockwise direction, and you will, in the fourth quadrant, only cos is positive, and if there you're doing 0 to 90 and 0 to minus 90, so you have to reverse it, right? So here theta is minus of base angle. Okay, now we have done with this polynomial. We can say when you put the polynomial p of x is equals to 0, it means x plus 2 into 2x minus 3 whole square, this should be equals to 0. Okay, and here we can say x plus 2 is equals to 0, or we can say 2x minus 3 whole square is equals to 0. So the x value is negative 2, and here 2x minus 3 is equals to 0, because we need to take a square root on both sides. So square root on this side and square root of this side, these are cancelled out, right? Okay, now here we can get x is equals to, shift the 3 on the other side becomes positive and 2 in the denominator, so negative 3 by 2, right? Now your x is replaced with cosecant square theta. So here we need to let x is equals to cosecant square theta, or 1 over sine theta, sine square theta. Cosecant is a ratio of sine, right? Okay, now replaced everything. Your x is 1 over sine square, which is negative 2, and or your x is 1 over sine square, which is equals to 3 by 2. Okay, now do the reciprocal on both sides. We can take reciprocal of both sides. Okay, so this reciprocal is sine square theta over 1 is equals to 1 over negative 2, and here sine square theta over 1 is 2 by 3. Okay, so you can cancel this over 1. Okay, now we have to take a square root on both sides to get rid of this square. So whenever we do the square root on both sides, the answer should be in plus minus, right? The square and the square root is cancelled out. Here we have sine theta is equals to plus minus square root of minus 1 by 2. We know that the square root of negative number does not exist. So we have no solution from here. Okay. Now let me solve the other case. Here we can say sine theta is equals to plus minus square root 2 by 3. Now we have two cases from here, with a positive root 2 by 3 and with a negative root 2 by 3, right? Let me assume these two cases over here and let me solve it. Okay, so here we can say sine theta is equals to root 2 by 3, and the other case is sine theta is equals to negative of root 2 by 3, right? Okay, so let me solve the principal value of the angle, or we can say the base angle in both cases. Theta is sine inverse of root 2 by 3. Okay, and here sine theta is positive, so according to the given range of values of theta, sine is positive in the first quadrant. And what is the theta value in the first quadrant? Your base angle. Okay, let me do this. So theta is your base angle, which is, let me solve this one, it should be in degrees, because this is from 90 to plus 90. Yes. Okay, let me convert it into degree mode, right? Okay, now sine inverse of, sorry, square root 2 by 3, 54.7, 54.7 degrees. Okay, so here we can say sine is positive in first quadrant. So in the first quadrant, what is the value of theta, which is your base angle, which is 54.7 degrees. This is your first solution. Okay, now let me do the second case. Now from second case, again we need to solve for the base angle, and for the base angle we have to consider it positive. Theta is sine inverse of root 2 by 3. For base angle we always consider it positive, and you will get the theta, the same theta, 54.7 degrees. Now here sine is negative. So according to the given range of value of theta, sine is negative in fourth quadrant, which is theta is minus base angle. Sine is negative in fourth quadrant. So if it is negative in fourth quadrant, your theta is your negative of the base angle, minus 54.7 degree. This is my second solution. So I will get two solutions for this equation from minus 90 to plus 90 degree. Question number 5, it is given that the integral from a to a cube 10 over 2x plus 1 dx is equals to 7, where a is a constant greater than 1. A should be greater than 1. Okay, part A show that a value is this. Okay, so we have to solve this integral, basically use this information that integration from a till a cube 10 over 2x plus 1 with respect to dx, this is equals to 7. Okay, let me solve this integration. So 10 is a constant. The integration of 1 over x is natural log of x, which is 2x plus 1, and we need to divide by the derivative of 2x plus 1 is 2, and we need to put the limits from a to a cube equals to 7. Okay, now when we simplify, 2 times 5 is 10. Further simplification, we have 5 natural log of 2x plus 1. Limits are from a to a cube. This is equals to 7. Okay. Now let me substitute the limits. We have 5 natural log of 2a cube plus 1. The upper limit is a cube, the lower limit is a. Subtract the lower limit is 5 natural log of 2a plus 1, that is equals to 7. Okay, we need to show that a should be equals to cube root of everything, right? So a should be the cube root. So it means we need to keep this term on the left side. Okay, so we have to make this term a cube equals to this. So cube root means this is a cube is on the left. So 5 natural log 2a cube plus 1 equals to 7 plus 5 natural log of 2a plus 1. Okay. All right. Now I flip this term on the other side. Let me divide both terms by 5. A cube plus 1 equals to 7 by 5, and here we can say 5 by 5 natural log of 2a plus 1. So basically I'm dividing both sides by 5. Okay, 5 by 5, this is cancel out, and what is 7 by 5? 7 by 5 is 1.4. Okay, 7 by 5, it's 1.4. All right, let's try. So this is 1 by 4. We are left with natural log of 2a cube plus 1 is equals to 1.4 plus natural log of 2a plus 1. Okay, now let me take exponential on both sides, right? Okay, so here e to the power natural log of 2a cube plus 1 is equals to e to the power 1.4 plus natural log of 2a plus 1. So what I did, I take exponential on both sides, e to the power this thing and e to the power this thing, right? E and exponential, this is cancel out. So we can say 2a cube plus 1 is left, and here e to the power 1.4 in the product e to the power natural log of 2a plus 1. So it's plus, so we can split it. Okay, now this is 2a cube plus 1 is equals to e to the power 1.4 is as it is, e and ln is cancel out, and we are left with the product of 2a plus 1. Okay, let me compare this with the given form, e to the power 4 into 2a plus 1. Yes, okay. Now 2a cube is over here, subtract 1, e to the power 1.4 into 2a plus 1, and let me subtract 1 on both sides and then divide by 2. A cube is e to the power 1.4 into 2a plus 1. This divides by 2 and minus 1 divides by 2. Okay, so 1 by 2 is 0 0.5. Yes, these two are 0 0.5. Okay, so a cube, this is 1 by 2, 0 0.5. A to the power 1.4 into 2a plus 1, and 1 by 2 is again 0 0.5. Okay, now taking a cube root on both sides, so cube root over here and cube root of this side as well. So when we take the cube root on both sides, this is cancel out, so a would be equals to the cube root of 0 0.5 e to the power 1.4 into 2a plus 1 and minus 0 0.5 with the square root, right? So this is the value of a. We need to show that the a would be equals to this cube root 0 0.5 into e power 1.4 into 2a plus 1 minus 0 0.5. Okay, so we got the value of a. All right. Now for part B, use an iterative formula based on the equation in part A. So this is equation in part A. We have to use that iterative formula to find the value of A correct to 3 significant figure. Use an initial value of 2. Give the result of each iteration to 5 significant figures. Okay. Now the iterative formula, we can write this iterative formula A subscript n plus 1. This is equals to cube root of 0 0.5 e to the power 1.4 into 2a subscript n plus 1, and everything is under the root, yes, minus 0 0.5, and the whole thing is under the cube root. So this is iterative formula, and the initial guess a naught is equals to 2. Right, now we have to give the values to n, right? When n is equals to 0, you have a1, which is equals to cube root of 0 0.5 e to the power 1.4 into 2a0, which is 2. We have given the initial value is 2, plus 1 minus 0 0.5. Okay, let me solve this. So we have cube root of 0 0.5 times e to the power 1.4 times 2 times 2 plus 1 and minus 0 0.5. This is up to each iteration up to 5 significant figures. So up to 5 significant figure, 1, 2, 3, 4, and 5. This is a fifth significant figure, right? Iteration, yeah, up to 5 significant figure, right? 2.128, and this is 2 rounded to, no, it's 1. 1, 2, 1, 2, 3, 4, and 5. So let's keep the 1 as it is because the next digit is 1. So 2.1281. 2.1281. Double check. 2.1281. Yes. Okay. When n is equals to 1, we have a2, which is equals to cube root of 0 0.5 e to the power 1.4 into 2a1 plus 1 and minus 0 0.5. Okay, let me simplify this. Okay, so here we can say this is 2 times 2 and here 2 times 2.1281. 2.1657. It's round to 57. 2.1657. Okay, let's do another iteration and value is 2. So we have a3, which is cube root of 0 0.5 e to the power 1.4 into 2 times a2. This is your a2, and plus 1 minus 0 0.5. Okay, let me solve this iteration. 2.1657. This is 2.1764. 4 rounded to 5 because the next digit is more than 5. 2.1765. 2.1765. Okay. Another iteration, when n is equals to 3, we have a4, which is equals to cube root of 0 0.5 e to the power 1.4 into 2 times a3. This is your a3 plus 1 and minus 0 0.5. Okay, so on the calculator we can say, okay, 2.1765765. 2.1795 up to 5 significant figure. This is 2.1795 up to so on. Now we need to guess the what is the value for a, right? Up to 3 significant figures. Yes, up to 3 significant figure, right? So here we can say that the value of a up to 3 significant figures is, what is the value for a? 2.18 if you round it to, which is 2.18. This is the value of a up to 3 significant figures. Question number 6. A curve has a parametric equation. X is in terms of t and y is in terms of t. Part A, find the expression for dy by dx in terms of t. Okay, so we have the function x. We need to differentiate the function x with respect to t because x is a function of t. Derivative of x with respect to t, here we apply the quotient rule, right? So the denominator function is as it is. We need to do the derivative d by dt of the numerator function e power 2t and minus 2 minus the numerator function e power 2t minus 2 and the derivative d over dt of the denominator function e power 2t plus 1 and everything divided by the square of the denominator function e power 2t plus 1 whole square. Okay, let me solve this. Dx over dt, this would be equals to e power 2t plus 1, and e power 2t minus 2 derivative is 2 times e power 2t, because e power 2t derivative is e power 2t and 2t derivative is 2, minus e power 2t minus 2, and its derivative is 2 times e power 2t. Everything divides by the square of e power 2t plus 1 whole square. Okay, let me simplify it further. We can say dx over dt would be, this is 2 times e power 2t, its product with e power 2t, and plus 2 times e power 2t, its product with 1, right? And minus 2 times e power 2t, 2 times e power 2t, its product with e power 2t, minus times minus is plus, 2 times e power 2t, its product with 2. Okay, e power 2t plus 1 whole square, right? Now you can see this is 2 e power 2t into, and with this is with positive, this is with negative, it is cancelled out. Okay, and we are left with dx over dt, this is equals to 2 times e power 2t, and plus 2 times 2 4 times e power 2t, and everything divides by e power 2t plus 1 whole square. This is 6 times e power 2t divides e power 2t plus 1 whole square. This is dx over dt, right? Now let me solve dy over dt, the derivative of y with respect to t. If I can solve dy over dt, this should be equals to e power 3t, and 3t derivative is 3, which is 3 times e power 3t. Okay, now let me solve the expression for dy over dx. Now here we apply the chain rule. So the chain rule is dy over dx is dy over dt into dt over dx. Okay, so dy over dx, this is the derivative of y with respect to t, which is 3 times e power 3t, 3 e power 3t, multiply the derivative of t with respect to x, means the reciprocal of this thing. So e power 2t plus 1 its whole square divides 6 times e power 2t. Okay, now let me find its simplified expression. So 3 times 1 is 3, 3 times 2 is 6, e power 2t is cancelled with e power 2t, so just e power t is left, right? So the simplified expression we can say is dy over dx, this is 1 by 2, okay, e power t into e power 2t plus 1 whole square, right? So this is a simplified expression for the derivative of dy over dx in terms of t. We need to find the expression of dy over dx in terms of t. This is dy by dx in terms of t. Now for part B, find the exact gradient of the curve at the point where the curve crosses y-axis. When the curve crosses y-axis, its x should be equals to 0, right? So we have x. So we can put just x is equals to 0 and solve for the t value, right? So we can say when x is equals to 0, it means the x value is, sorry, this is your x, 2t e power 2t minus 2, and this in the denominator we have plus 1. So here we can say e power 2t minus 2 divides e power 2t plus 1, this is equals to 0. So this term multiplied by 0 is 0. So from here we can say e power 2t minus 2 should be equals to 0. E power 2t is equals to 2. Okay, and taking natural log on both sides, natural log e power 2t is equals to natural log of 2. So 2t natural log of e is equals to natural log of 2. Natural log of e is equals to 1. So this thing is 1. 2t is equals to natural log of 2. T value is natural log of 2 divided by 2. So we get the value of t. Okay. Okay, now we got the t value, right? Okay. Find the exact value of the gradient of the curve at the point where the curve crosses y-axis. When the curve crosses y-axis, the x component equals to 0. When you put x component equals to 0, you will get some t. So just substitute the t value over here, you will get the exact gradient of the curve, right? dy by dx is, you can say, the gradient of the curve is dy over dx, which is half e power 2t into e power 2t plus 1 whole square. This is just e power t, sorry. This is e power 2t plus 1 whole square, right? Now let me solve this gradient. The exact gradient at t is equals to natural log of 2 divided by 2. Okay, this is 1 by 2 e power natural log of 2 by 2 into e power 2 times natural log of 2 by 2 plus 1 whole square. Further simplification, we have 1 by 2 e to the power 1 by 2 and natural log of 2. This is 2 is cancelled with 2, e to the power natural log of 2 plus 1 whole square. And this is 1 by 2 e natural, when we have log, so this term, the coefficient of log goes to the power. So natural log 2, its power is 1 by 2, and e and ln is cancelled out, just 2 plus 1 its whole square. So we know that this e and this ln is cancelled out, just 2 is left, right? This e and this ln is also cancelled out, right? Okay, now here we have 1 by 2, 2 to the power 1 by 2, 2 plus 1 is 3, 3 square. Okay, and we have square root of 2 divided by 2, 3 square is equals to 9. So we can say the exact value of the gradient of the curve is 9 by 2 square root of 2. So this is the exact value of the gradient of the curve. All right. Question number 7, part A. Prove that cos of theta plus 30 degree into cos of theta plus 60 degree would be equals to this. Okay, so let me start from my left hand side. This is the left hand side. Okay, so cos A plus B formula we have to use over here. So let me use the formula of cos A plus B is equals to cos A cos B minus sine A and sine B. Okay, so first we have cos theta plus 30 degree into cos theta plus 60 degree. Let me open this. This is cos theta cos 60 30 minus sine theta sine 30, bracket, in the product we have cos theta cos 60 minus sine theta sine 60. Okay, so what is cos 30 and sine 30? My calculator is in degree. Okay, so cos 30 is root 3 by 2. So cos theta into square root of 3 divided by 2 minus sine theta sine 30 is 1 by 2, I guess. Sine 30 1 by 2, 1 by 2 bracket cos theta, cos 60, cos of 60 is 1 by 2 minus sin theta, sin 60 square root of 3 by 2. Yeah, okay. Now here we have root 3 divided by 2 cos theta minus 1 by 2 sin theta, 1 by 2 cos theta minus square root of 3 by 2 sin theta. Okay. Now let me do its product, right? Because both are in the product. Okay. So first multiply root 3 by 2 cos theta with 1 by 2 cos theta minus square root of 3 by 2 sin theta. Distribute basically. And minus 1 by 2 sin theta. It is distributed on the second bracket, half cos theta minus square root of 3 by 2 sin theta. Okay. All right, so here we have to distribute it. Square root of 3 by 4. This is square root of 3 divided by 4. Cos with cos is cos square theta. And minus square root of 3 into square root of 3 is just 3. 2 times 2 is 4. Cos into sine. Cos theta sin theta. Okay, this is minus 1 times 1 is 1. 2 times 2 is 4. Cos and sine. Negative times negative is positive. 1 times root 3 is root 3. 2 times 2 is 4. Sine into sine, sine square theta. Okay. Let me combine this. Square root of 3 by 4 cos square theta plus square root of 3 by 4 sine square theta. This first term and this last term. Okay. Now 4 is in the denominator. This is cos theta, sine theta, cos theta, sine theta. Minus 3 minus 1 by 4. Minus 3 minus 1 is minus 4. Minus 4 by 4 is just minus 1. Cos theta, sine theta. Okay. And here we have to take root 3 by 4 common, and cos square theta plus sine square theta is left, and minus cos theta sine theta, right? And here we know the identity that cos square theta plus sine square theta is always equals to 1. So put this equals to 1, right? So here we have root 3 divided by 4. This thing is 1 minus. Okay, now we have to make this sine 2 theta. Okay, multiplying and dividing by 2. Multiply by 2, divide by 2, sine theta and cos theta. Here we use a sine double angle formula. Sine 2 theta is equals to 2 sine theta cos theta. 2 sine theta cos theta sine 2 theta, right? So this is equals to 1 by 4 square root of 3 minus 1 by 2 sine 2 theta. That is my right hand side. 1 by 4 root 3 minus half sine 2 theta. This is exactly the same. So I split 1 by 4 root 3. This 2 sine theta cos theta would be sine 2 theta, and minus 1 by 2 is outside, right? So it is proved. Now for part B, solve the equation 5 cos 2 alpha plus 30 degree cos 2 alpha plus 60 degree is equals to 1. Okay, so here we can say from part A, what we have done in part A. Cos theta plus 30 cos theta plus 60 is equals to this. Okay, cos theta plus 30 into cos theta plus 60, this is equals to square root of 3 by 4 minus sine 2 theta divided by 2. Okay, now we can say we need to just solve this. What is this thing? Okay, so here we can say let theta is equals to 2 alpha. So replace theta by 2 alpha. So cos of 2 alpha plus 30 degree into cos of 2 alpha plus 60 degree. This is equals to square root of 3 divided by 4 minus sine of 2 into 2 alpha divided by 4. Okay. Now we have to multiply both sides by 5 to make this term, right? Okay. We can say multiplying by 5 on both sides. Okay. 5 times cos 2 alpha plus 30 into cos 2 alpha plus 60. This is equals to square root of 3 by 4 minus sine 4 alpha by 4 by 2. Sorry, this is by 2 and the orange one, this is by 2. Okay, we have to multiply this side by 5 and multiply this side by 5 as well. So here we can say this whole thing is with 5. Okay, now we have done with the left hand side. So this whole left hand side is this, that is equals to 1. So here we can say compare with question. We need to compare with the given question. Okay, and after comparison we come to know that this whole thing is 5 root 3 divided by 4 minus 5 by 2 sine 4 alpha, that is equals to 1. Okay, now we need to just solve. Okay, and for alpha value is between 0 to 90 degrees, so alpha lies in first quadrant only, 0 degree till 90 degree. Okay, so shift this term on the other side. We can say minus 5 by 2 sine 4 alpha is 1 minus 5 root 3 divided by 4. Okay, and sine of 4 alpha, this would be 1 minus 5 by 4 square root of 3, and this thing divides by minus 5 by 2. Okay, let me simplify this. Okay, we have 1 minus 5 square root of 3 divided by 4, everything divided by minus 5 over 2. This is 4 minus 4 plus 5 root 3 over 10 minus 4 plus 5 square root of 3 over 10. Okay, now the angle over here is 4 alpha, and in the domain the angle is just alpha. So if this is alpha, we can say 4 of alpha is 0 times 4 is 4, and what is 4 times 90? 4 times 90, 360. So this is in 360. So this 4 alpha is between 0 to 360 degree, right? This is the equation for sine. So from here, sine of 4 alpha is minus 4 plus 5 root 3 over 10, and the domain of 4 alpha is 0 is less than 4 alpha. 4 alpha is less than 360 degree. So 4 alpha is between 0 to 360 degree. Okay, and we know that sine is positive in first and second quadrant, right? So if I can draw from 0 to 360 degree, okay, so this is 0 and this is 90, this is 180, this is 270, and again this is 360 degree. Okay, so in the first quadrant, all trigonometric ratios positive, sine is positive, tangent is positive, and cos is positive, right? Sine is positive. So if I can do minus 4 plus 5 root 3 divides 10. Is it positive? Yeah, this whole thing is positive, right? So this tell us that sine is positive in first and second quadrant. So in the first quadrant, your angle is your base angle. And what is the angle? Angle is 4 alpha. This is your base angle. And in the second quadrant, your angle is pi minus the base angle. Okay, now let me solve the base angle first. Okay, base angle we can say, or the principal value of angle, which is 4 alpha, is equals to sine inverse of this whole thing, which is minus 4 plus 5 square root of 3 over 10. Okay, you will get some angle 4 alpha, and this should be in degrees, right? My calculator is in degree mode, thank god. Do sine inverse of answer 27.8 7766, 27.7766 degrees, right? This is your base angle. Okay, now we can say sine is positive in second and fourth quadrant. Sorry, second and first and second quadrant, I messed up, sorry. It is positive in first and second. Sine is positive in first and second quadrant, sorry, first and second. So what is the angle in first quadrant? Your angle value is 4 alpha, and that is your base angle, which is 27.7766 degree. And what is your alpha value here? Is 27.7766 divided by 4. You will get some alpha. Sorry. Okay, so this thing divided by 4, 6.944 or 6.9. So from here we have alpha is equals to 6.9 degrees. This is your first solution. Okay, so this is a solution for the first quadrant. Sine is also positive in the second quadrant, which is 4 alpha is pi minus the base angle, right? Now for the second quadrant, your angle 4 alpha is pi minus the base angle 27.7766 degrees. Not pi, it's 180 because it is in radians, degrees, sorry. So here we do 180, 180 degree minus that angle, okay? So 180 degree subtract 27.7766, which is 152.22. So 4 alpha is 152.22, and alpha would be equals to 152.22 divided by 4, right? So here we can say that, okay, this thing divides by 4, we have 38.05 or 38.1 degrees. So alpha is 38.1 degrees. So here you can see both the solutions are in the range from 0 to 90 degrees, 6.9 and 38.1. These are the two solutions for this equation, and they are in the range from 0 to 90 degree. Now for part C, show that the exact value of cos 20, cos 50 plus cos 40, cos 70 is half root 3. Okay, so let me write down from part A. We have done the part A that proves the left hand side equals to right hand side. So this is B. So this is part A. Cos theta plus 30, cos theta plus 60 in the product. Cos of theta plus 30 into cos theta plus 60, this is always equals to 1 by 4 root 3 minus half sine 2 theta. 1 by 4 root 3 minus half sine 2 theta. Okay. Now we have to solve this first. Sine cos 20 cos 50. How do we make it 20 and how do we make it 50? From 60, if you subtract 10, it's 50. From 30, subtract 10 is 20, right? So here we can say let theta is equals to minus 10 degrees. When theta is negative 10 degrees, right? So here we have cos minus 10 plus 30, cos minus 10 plus 60. This is 1 by 4 square root of 3 minus 1 by 2 sine 2 and theta values negative 10. Okay. So here we have cos of 20 degree and cos of 50 degree. This is square root of 3 divided by 4 minus 1 by 2 sine of minus 20 degrees. Okay. All right. So this thing sine 20 and sine 50. Sorry, cos 20 cos 50 we have done with this. Name it part 1. Okay. Now by using this again, how do we get 70 and 40? In 60 add 1, 10 is 70, and 30 add 10 is 40. So we can say let theta is plus 10. Let theta equals to 10 degrees. When you put theta equals to 10 degrees, we can say cos of 10 plus 30, cos of 10 plus 60 is 1 by 4 square root of 3 minus 1 by 2 sine 2 into 10. Okay. So simplify, this is cos 40 cos 70, that is square root of 3 divided by 4 minus 1 by 2 sine 2 times 10 is 20 degree. This is my second expression. Okay. Now here we can say put these two expressions in the question, right? Add, we can say add equation 1 and equation 2. Okay. We need to add both of them, right? So the equation 1 is cos 20 cos 50 plus cos 40 cos 70, that is equals to root 3 by 4 minus 1 by 2 sine minus 20 degree. Add this expression, square root of 3 by 4 minus 1 by 2 sine 20 degree. Okay. All right, so we know that sine is an odd function. It do not absorb the negative sign. So the negative sign is outside. This is root 3 by 4 root 3 by 4. There is 2 times of root 3 by 4. And we have negatives times negative is positive, 1 by 2 sine 20 degree. And here we have negative of 1 by 2 sine 20 degree. So with the positive and with the negative, both are cancelled out. Okay, 2 times 2 is 4. Okay, now you will get this expression that this is equals to square root of 3 divided by 2. So cos 20 cos 50 and its sum with cos 40 and cos 70, that is equals to square root of 3 by 2. So we just need to show, right? Okay, so we have done that. The exact value of this expression is square root of 3 by 2. Right. So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.